All right, we've started up. For everyone just joining, thanks for joining. We're just going to give it about 1 minute and we'll kick this off. So thanks for your patience. We'll just let a few people get their Zooms set up and rolling. We'll give it about 30 seconds for folks to join and we'll kick off. Thanks for joining and thanks for your patience. Okay, 3:01 p.m. in Australia. I reckon we'll kick this off. Thanks to everyone who's joined. Let me introduce myself. I'm Matt Grover, the Director of Energy Markets here at Fluence in Australia. And let me introduce you to my colleague, Sam Markham, who's also with us. She's the Manager of Growth for our APAC team. And Sam and I are going to walk you through a presentation we prepared today about hybrid assets in Australia's national electricity market, in the NEM. And the agenda we're going to run through, we're going to try and cover a presentation in about 30 minutes and leave some time for Q&A at the end. So if anyone has questions as we go, please pop them into the chat button in Zoom, and we'll tackle those all at once at the end. And we'll try and keep this snappy. We're going to start by explaining what a hybrid is in the context of the NEM and why you might build one. We'll talk about some of the key choices and trade-offs you'll have to make in deciding what type of hybrid to build and how to operate it. And we'll talk a bit about revenue optimization and how you would actually trade and operate one in the market. And then, yeah, we'll sum up and save some time for Q&A. So that's the plan, and we'll jump right into it. Firstly, just to introduce Fluence. Fluence is a leading supplier of battery systems and associated services globally. Fluence has three main business lines. We provide energy storage systems, also O&M services to help operate those systems. And we also provide optimization software and a route to market interface in select global markets. And relative to operating a standalone battery, operating a hybrid plant is going to require an evolution of capabilities from basically all three of these aspects of a business like Fluence. You're going to need improved capabilities from your physical plant, from your O&M services, and your optimization software. And all three of those elements are going to need to be more tightly integrated than they have been in the past. So those are some of the nuances we're going to seek to highlight in today's presentation. And I'm going to do the first bit, which is how to define a hybrid system in the context of the Australian national electricity market. So there's three types of battery plant that exist here in the NEM today. There's firstly standalone BESS, standalone battery systems that people should be familiar with. There's a few dozen of these already. You know, in the eyes of AEMO, the market operator, power system operator, this just looks like to them like one plant. We also have a handful of co-located battery and renewable energy plants in the NEM today, where battery is sat right next to a wind farm or a solar farm, located basically in the same place. They might have the same name, but electrically they are independent plants, and to AEMO they look like two independently operating plants. And the common denominator with both these types of systems is they're developed and approved and connected and operated individually. And what we're going to talk about today, focus on mostly, is hybrid battery plants. And there are none of these yet in the NEM today. No plants are yet operating and registered in this manner, but there are several projects that have reached financial close and are under construction and going to start operating soon, which is exciting. And the key difference here is that the two individual plants share a connection point and are developed and connected and registered and bid and operated together or in concert. And what AMO sees can be complicated depending what type of plant, some of the configuration choices that you make in setting your plant up. And we're going to talk about what some of those different permutations look like today. So what problem are hybrid assets trying to solve? Well, in the Australian context, the main problem is that we're building renewables into an increasingly congested power system, and our renewable assets are experiencing undesirable amounts of curtailment due to both the power system being congested at times, requiring assets to curtail, but also because the price of electricity is negative, an increasing proportion of the time, and therefore uneconomic for generators to generate. We often have too much generation relative to the amount of load available in certain parts of the grid, which causes negative prices, which is not great for business cases. But batteries are one of the solutions to this problem. So enter the hybrid asset. So why would you build a hybrid plant, a hybrid battery, relative to building a standalone battery or a co-located battery right next to your wind farm or your solar farm? Well, the answer is complicated, and you'd have to consider both your project's costs and also its revenues. So on the cost side, there's pros and cons of going hybrid. You might realize CapEx cost decreases by having a smaller or a single grid connection. So the battery and the solar farm share a single grid connection. You might be able to use fewer transformers, or if you DC couple your plant, you have fewer inverters, or could be CapEx savings and all that. On the downside, going hybrid probably makes your GPS, your grid connection approval process more complex, and you'll have a necessarily more complex control system. And on the revenue side of the ledger, there are pros and cons. You might get revenue increases from having more favorable PPA terms if you can work out a creative PPA on the back of your hybrid project. You might be able to curtail your renewable plant less, create more LGCs, things like that. On the downside, you might have limited grid connection headroom, which requires a trade-off between whether you generate with your battery or your solar farm. They can't generate at their max capacity at the same time. Your battery may have to operate suboptimally sometimes to manage the renewable generator, and probably your battery will receive reduced FCAS ancillary service revenues relative to if it had been a standalone battery. And we think that the potential for revenue increases are probably certainly magnified if your renewable generator experiences a lot of curtailment. That's where you'll see a lot of benefits if you have a renewable project in a suboptimal part of the power system. And we also think that hybrid plants are very likely to realize reduced FCAS revenues due to several complexities and practicalities with the way FCAS is managed and dispatched. So will you get a better project IRR by going hybrid relative to going standalone? It depends on the balance of these factors, but these are the key factors that we think that product developers should be thinking about. And I'll hand over to Sam to lead us through the next section, where we're going to talk a little bit about some of the key new choices that hybrid project developers will have in deciding how to set up their plant.
Thanks, Matt. So as Matt kind of foreshadowed, the IESS rule change has enabled 4 new configuration choices. So first off, so the first decision is how many inverters you have. So this is the AC versus DC coupling choice. The second is how you classify your plant. So that relates to how it's registered with AEMO and how many dispatchable unit identifiers you choose to have. So the example on the screen has 2 DUIDs, but you can easily do 1. The third is how many meters or sub-meters you have and where you place them. And the fourth is how you manage conformance with dispatch targets at the connection point. And so that is functionally part of your unit classification, but it is this new thing to call out. So I'll now talk through two illustrative examples to highlight the benefits and trade-offs of those first two decisions. So the AC versus DC coupling and 1 versus 2 dispatchable unit identifiers. So example A will cover DC coupled and 1 DUID for a hypothetical solar plant and battery. And example B will cover AC coupled with 2 DUIDs for the same solar plant and battery. So jumping over to the first one, so as you can see here, it's DC coupled. And so what that means is there's multiple assets located behind the same inverter. So some insights from this, it can be effective for developing a greenfield site, although you have to consider DC to DC converters. Second is likely to experience fewer energy losses when charging the BESS directly from the solar plant relative to AC coupling. However, the drawbacks are it can be harder to retrofit and comes with greater engineering risk if you were to add a battery to an existing solar plant. And there's possibility of complex inverter modes and limited grid export charging capability at certain times. Going on to decision 2, that's the plant classification. We've gone with 1 DUID here, so 1 dispatchable unit identifier. And so it's potentially operationally simpler because for 2 assets, the BESS and the solar, there's now 1 set of bids and 1 control system mode that AEMO sees. However, there's reduced operational flexibility, so there's no option to utilize aggregate dispatch conformance. It's just kind of part of it being 1 DUID. And the second is that the BESS must consume some cycles buffering the unders and overs of the VRE forecast. And that's because functionally, under a 1 DUID hybrid, the assets must be a scheduled bidirectional unit. And so it must be capable of meeting its dispatch targets at all times. So in instances where there's an error in the solar forecast, the battery would have to make up that difference. So on to example B. So this is AC coupled. So that's where there's essentially 2 separate assets, each with their own inverter. So this can be effective when considering retrofitting BESS to an existing plant. And it can be also helpful if you're looking to leverage expertise by developing those assets independently. However, AC coupling can face greater energy losses when charging the BESS from the co-located solar plant rather than from the grid relative to DC coupling because of the conversion from DC to AC and then back. Decision 2, so 2 DUIDs, this offers greater operational flexibility because you can have the battery in this case operating as a scheduled bidirectional unit, but for the solar plant, you can take advantage of it being a semi-scheduled generator and the flexibility that that provides. So VRE can be naturally under or over dispatching targets with no BESS buffering required because as far as AEMO's dispatch instructions are concerned, they're 2 different assets. It's just that behind the connection point, reactive power needs to be consistently managed. And the third benefit of 2 DUIDs is there's the option to take advantage of aggregate dispatch conformance at certain times. So this is just 2 of many possible configurations. And so this table is really just a takeaway for everyone on the call on when it's best and the drawbacks to keep in mind for each of the decisions that we've just gone through. And then I'll pass back to Matt.
Thanks, Sam. The next bit we wanted to cover was a bit about market operations and actually trading a hybrid plant in the market and how you would manage a plant in the market and manage its revenue. So relative to a standalone battery, a hybrid battery renewable generator plant is going to need to forecast several things very well. Batteries already seek standalone batteries already seek to forecast their prices, and there's several different prices of different services that you need to be forecasting and keeping an eye on in them. A few of them listed there, namely the prices for energy and ancillary services, but also forecast for your local dispatch price and your likelihood of being constrained. But what's new in a hybrid is that these plants are going to need to be much better at forecasting their own physical availability and signaling it through to the market. So you're going to need to have probably a bidding system sitting kind of at the center of the operations of your plant that is forecasting several things: the availability of your wind or solar resource, how likely you are to be constrained off, and have constrained energy available to the battery. You're going to need to be forward planning your battery through those prices and those renewable availabilities. And one of the main new aspects of a hybrid plant operation is that many hybrid plants are going to share a grid connection. So you might have a 100 megawatt grid connection with a 100 megawatt solar farm and a 100 megawatt battery behind the grid connection. And how you manage that limited headroom and the availability of those two assets to make sure you're managing them optimally and compliantly, and not doing silly things like trying to make them violate the headroom constraint, will be super important. And you're going to need to have a bidding system that will be continually forecasting availability and signaling and re-signaling it through to AEMO for the whole dispatch horizon, call it 24 hours ahead of time. So availability forecasting is going to become even more important than it is today. And we've got a diagram here about the role of the bidding system in all of this. And at most grid scale battery projects, the optimization and bidding system is already central to that battery's market participation. It makes all the key decisions about when the battery is going to charge and when it's going to discharge and when it's going to sell FCAS, ancillary services, and how much. And the role of the bidding system is going to become even more central and more important in a hybrid plant, because there are several new things that the bidding system will be doing on behalf of the plant, and several new interfaces to other systems that get introduced when you've got a hybrid plant. So this is a stylized example of our optimization and bidding system we call Mosaic, which is widely adopted across the NEM. Lots of renewable generators and big standalone batteries today. And the role it plays at a standalone battery today is in providing an interface for the trading team to communicate commercial constraints in a trading strategy for the battery. And it forecasts prices. Those are a key input to any optimization system. And it has an integration to AEMO for receiving dispatch targets and submitting bid files and things like that. What's new in a hybrid plant is a couple extra additional interfaces and complexities, where now for the first time, your battery's optimization and bidding system needs to also be aware of your solar or your wind forecast, so that it can be planning the utilization of the battery around that wind or solar forecast, and utilizing the available grid connection headroom optimally and efficiently. So that's a new role that the bidding system will have to play. And the second new interface and new role is that it needs to be a linkage and an integration between your bidding system and your plant control system in a way that is not required or needed at a standalone battery, where there's going to be instances for a hybrid plant. And I should have mentioned, this diagram illustrates one of the several types of configurations Sam walked through. This illustrates a configuration where you've got a plant that's chosen to classify and use two dispatchable units. So chosen to bid and operate the solar farm in this example and the battery independently. And in a setup like that, you're going to have instances where you have the option to utilize a new mechanism, that's a relatively new mechanism called aggregate dispatch conformance, where you can choose to self-dispatch your battery to make up your dispatch target at the connection point and avoid curtailing your solar farm, to give one example or one application. So There will be times when your bidding system needs to direct or instruct that action and that efficient utilization of that new option to utilize aggregate conformance. And of course, these hybrid plants will need to have some kind of modern and sophisticated hybrid power plant controller that interfaces with AEMO on behalf of both plants, and which is capable of directing energy flows behind the connection point and ensuring that both your solar farm and your battery are receiving their dispatch targets and getting the right set points to make the right ramps and to follow their dispatch targets at all times. There's also several new flags that AEMO is going to be publishing, telling these plants when they're allowed to do certain things and when they're not, that the bidding system will need to be picking up and the control system will need to be picking up and respecting. So there's a bunch of new signals, new optimization decisions to make, and new system integrations to operate any hybrid plant. And we think that bidding systems like ours are necessarily must basically sit in the center of everything that happens at a hybrid plant. And we just have a bit of a few takeaways and final messages to kind of recap and open a bit of Q&A. So I'll hand back to Sam to summarize kind of the key challenges as we see them.
Thanks, Matt. And please, everyone, we've seen a few questions come through, but put all your questions in the Q&A box and we'll try and answer them. So as you can see from this slide, hybrids are harder, but potentially more rewarding, is what we hope you take away from this presentation. And so the three key things that we've tried to highlight in this presentation and then summarize in this slide are partner selection, plant configuration, and bidding and operations. So for partner selection, the challenge is there's unproven technology models, extra systems interface risk. And so we consider the solution for that is to select an experienced technology provider with proven grid models and demonstrated expertise in this area. Second is plant configuration. So that relates to those decision choices and consequential trade-offs. So the solution there is to make decisions with an awareness of both the plant's physical capabilities and the expected consequences for market revenues. And then the third is bidding and operations. So bidding systems require several additional system interfaces, new optimization decisions, and a heightened awareness of plant capabilities, which Matt just talked through with the flow chart. So the solution for that is selecting a proven bidding system provider with experiences that is experienced with the nuances of bidding and dispatch and can effectively manage the hybrid. And then one more slide. So final slide, Fluence can supply an integrated technology to hybrid projects. So on our hardware side, we've got a battery energy storage system and a hybrid power plant controller. And so that is suitable for AC applications and provides seamless integration with PV and wind from any OEM with the Fluence battery energy storage in one central control system. And then we also have engineering grid models available to meet NEM grid code requirements for retrofit, greenfield, and grid forming applications. And then on the right, we have our Mosaic bidding system, which Matt has talked through a bit today. And so what we can offer there is 1 and 2 DUID unit classifications for scheduled and non-scheduled assets. It can cover all PPA and contract structures and manage this aggregate dispatch conformance. So I think we'll open up for Q&A.
Yeah, those are all the key points we wanted to hit. Thanks for sticking with us. I hope that wasn't too much detail crammed into 25 minutes, but hopefully interesting. We've got a few questions through the chat, which I'll pick up maybe the first couple and have a go at. There's a question from Inez, and hi Inez, good to hear from you. A few questions from Inez, but there's a good one about where she's asked, are there significant financial or market participation revenue differences between the two hybrid options? And I presume you're talking about using one DUID versus two DUIDs. That's a good question. In general, our understanding is that the main reason you would choose one DUID, the main determining factor for why you would choose to classify with one DUID versus two DUIDs probably relates to the capabilities of your physical kit that you're planning to use, that you've selected. Some, as we understand it, some control systems are only kind of capable of operating in a single mode, where the battery constantly makes up and buffers out the unders and overs of the renewable resource, which is a simple but easy to understand mode of operation. In that instance, one DUID is probably your only clear pathway or most viable option for classification. We do think that's probably less optimal from a revenue perspective. It's certainly less flexible in the way your plant chooses to operate in the market. Whereas in contrast, if you can use a two DUID classification, because your control system and your physical plant can accommodate the varying and changing modes of operation, we think that's more flexible, affords more flexibility, and probably will result in higher overall revenues. Probably the two main reasons for that are, under a two DUID classification, your solar farm, to use solar farm as an example, looks like a solar farm 99% of the time. It just does what a solar farm does. It can be a little under and a little over its dispatch target based on resource availability, and that's okay. Whereas for a one DUID hybrid, that's not okay. And your battery needs to be constantly doing work and consuming cycles and managing its energies to guarantee that it can buffer out those unders and overs. So I hope that answers your question. We think that probably the two DUID setup is more flexible and therefore more revenue optimal, but only if your plant and your control system can operate in that manner. Sam, do you want to pick a question and have a go while I look for my next one?
Yeah, so we've got one question from Robin, which is, can we have two DUIDs for a DC coupled hybrid project, one for a BDU and one for semi-scheduled? So our understanding is yes, you can. So the two configurations we showed are just two examples, but from what we've seen, any combination of those is possible. So AC coupled with one or two DUIDs and DC coupled with one or two DUIDs as well.
Yes, subject to your plant being able to meet its requirements and operate in that mode. I believe that's my understanding as well. Someone's asked a question about wasn't AMO requiring standalone batteries to have two DUIDs? That's a good question. We could have addressed that. The same package of rule changes that Sam mentioned early on, it was IESS, Integrating Energy Storage Systems. One part of that rule change was that about a year ago, all the standalone batteries in the NEM switched from using two DUIDs to one. And so that's why in our presentation, all the batteries are represented as with one DUID and with a label scheduled BDU, which is a scheduled bidirectional unit, which is the new technical term for AMO's new technical term for a big grid scale battery. Good question.
So another one is, well, actually there's a few are kind of along this similar line, is there a significant difference in the approval time when obtaining two DUIDs compared to one? Do you want to start off with that, Matt, or shall I?
I'm not an expert on that part of the development process, but I would imagine that the part of the development life cycle with the most room for complexity and time delays is the GPS, the grid studies and the GPS process. So from the limited perspectives we've heard from developers who are out there trying to do this, DC coupled stuff is harder and takes longer, and there's more tricky technical attributes to fit into those models and align with AMO on. But from a registration perspective and a construction perspective, I would imagine there's not much of a difference. Is there anything
Yeah,
to
that's
add to
my
that, Sam? Yeah.
no, that's my understanding as well.
There's another question from Inez. Why is it harder to retrofit? And in general. And I think the short answer to that question is that one of the biggest complexities with retrofitting is just opening up the existing GPS for your wind farm or your solar farm, and potentially impacting needing to open up any or impacting any PPA agreements you might have signed on that wind farm or solar farm. So, as I understand it, those are two of the biggest technical and commercial barriers to existing asset owners taking the leap and retrofitting a battery onto their sites.
And I think I'd just add, if it relates to whether to go to DC coupled versus AC coupled, from what I understand about the process, DC coupled, it's very challenging to retrofit with a new type of kit from a different OEM, and the sizing and other limits that come in when adding it just creates a lot of complexity. Sorry, that's a very economist explanation of a deeply technical term. But Inez, if you have any more questions on that topic, we're happy to take them on notice as well.
Yep. There's a good question here from Scott Partland. G'day, Scott. For an AC coupled renewable battery hybrid, does the control system setup require separate meter feed for each technology to correctly control the facility? I think the short answer is yes, but we should differentiate here between revenue metering and real-time SCADA. So there is lots of optionality in the IESS rules about how you configure a plant and where your meters go. But in its simplest form, an AC coupled hybrid like the one you described could have a single revenue meter at the gate, so just one revenue meter. But AMO is going to require you to put SCADA on each individual component of the plant, and in RTAC or whatever to give AMO real time visibility on the both the solar farm and the battery. So hopefully that answers your question. Yeah, AMO needs to see everything that's going on, regardless of how you're choosing to settle with the market.
All right, I've got one more for you, Matt.
Sure.
So from an anonymous attendee, if you were fully constrained in the market, could you still charge your battery with the VRE output for both AC and DC coupled?
Short answer, good question. Short answer is yes. And then the two caveats are, one, assuming your physical kit can do that. And from what we understand, that some DC coupled inverter solutions have some caveats or limitations about how much grid charging they can do, and often they can't charge at the same power level they're registered to discharge at. But so assuming plant's technically capable, yes, you could dispatch your battery to avoid curtailing your renewable plant, but only if the AMO flags allow you to. And if you're familiar with the way constraints impact wind and solar farms in the NEM today, if you're an operator of an existing plant, you're probably well familiar with the problem. Curtailment, grid constraints and curtailment happens for different reasons. And AMO is retaining the optionality to differentiate the different types of constraints and allow you to use aggregate conformance in some situations, but not others. So to oversimplify, AMO is going to allow you to use aggregate conformance if your your solar farm, for example, is being constrained for like a thermal line limit reason. But if the constraint that's binding and affecting your plant is more technical in nature and due to system strength or some kind of voltage stability issue, they may not allow you to use aggregate conformance. So there's going to be a new flag that AMO publishes every 5 minutes for every dispatchable unit that tells you whether it's an interval where you're allowed to use aggregate conformance or whether you're not. So that's just another one of those new complexities in the dispatch process that your bidding system is going to need to be watching out for and considering in its optimization decisions.
So another one is, can the BESS charge from the grid and the PV/wind asset at the same time? So I can start with this, Matt, if you'd like.
Yeah, please.
So the short answer is probably. So it really depends on how much you're looking to charge. Obviously, if you're charging a BESS, you can't charge more than that BESS is capable of charging in a very in a short period of time. But you could potentially half split between what's coming from your co-located PV or wind and what's coming from the grid. The, I guess, caveat there is that we understand with DC coupling that there can be certain modes that those assets will operate under. And so what that could mean is at certain times, maybe that asset will limit from charging just from the co-located asset or just from the grid. So the example I've just given is it works as far as we understand from an AC coupling perspective, but it could be limited from a DC coupling perspective. Matt, did you have anything you wanted to add?
No, that's great. There's a good question in here where someone has asked, is there an ideal size or duration of a battery in a hybrid project relative to the standalone? It's a complex question. And I imagine there's a few folks on the call who have thought about this and are developers or financial modelers trying to work out the optimal battery size. From the limited modeling we've done, the perspective is generally as big a battery as you can afford to put in and your site can accommodate. We think for a solar farm in particular, there's the revenue trade-offs of having limited grid connection, and there's limited conflict between when the batteries typically wanting to generate or sell FCAS and when the solar farm is wanting to generate. So you could generally at a solar farm size the battery up to the size of your solar farm without much regret. But there may be folks in the market who have more nuanced perspectives on that than I do. There are for a wind farm, I imagine it's an altogether different consideration because the nature of that generation profile would dictate quite a different battery sizing consideration. And certainly, if you have a one DUID configuration of your hybrid plant where your battery is required to be buffering out those unders and overs, that would be a key consideration you need to consider in deciding what size and duration battery to put in. The one DUID wind farm gives me nightmares just thinking about how much energy that battery would have to reserve to make sure it was always there to back up the wind farm. So I hope that answers the question.
So another one from an anonymous attendee. How much more difficult is the hybrid grid connection study process compared to a standalone BESS? For example, is it 60, 70% more work? So I think here the real comparison is not a fully fledged hybrid compared to a standalone BESS. It's whether it makes sense to have two independent assets or have a hybrid. So from our perspective, the real difference is that you're doing one connection study, one connection like GPS process rather than two. So that would be, I think, the biggest distinction there. I hope that answers the question.
A couple more here. Scott, I see a note. We haven't quite nailed your metering question, but let us take this one on notice and follow up with you after. Make sure we get you the right info. There is another question here about just asking about one of the schematics that we showed, where the question is there a missing meter at the point of connection? And is it that point of connection meter that would be used by AMO to assess compliance for aggregate conformance? Probably yes. All those diagrams we showed were somewhat liberally stylized. So apologies if some of the nuance didn't come through. But in general, we were intending to stick a meter, fairly close to the point of connection there to show that that's generally where the revenue meter will sit. And that's exactly the point at which AMO is looking for your plant to meet its multiple individual dispatch targets in the aggregate. So, spot on.
So another one is, are there advantages to a standalone BESS having two DUIDs, or are they now gone with AEMO's changing classification? So to start off, the old classification did have two DUIDs for every asset, but it was a load side and a generation side. And so the bidirectional unit has both load and generation as part of the same thing. So from that perspective, as far as I understand, it's just bidirectional units. You can't have a gen and a load anymore. I hope that answers the question. If there's more, please add a follow-up.
Yeah, that's right. It's a big, complex technical change that AMO implemented that didn't really change anything. Batteries still operate as if they're a generator and a load. They just do it under one DUID now. It was to get on my soapbox for a moment, a large and expensive change for the whole industry to go through that didn't really create any appreciable benefits or changes. But yeah, all the batteries in the NEM, all the big ones, are using one DUID now.
So one question on the GPS process. So the question is, GPS process 539 versus 534, what is more or less efficient and has less delays? So on this, obviously there's no hard and fast answer, but just based on what we've seen from customers in the market, the 539 is a bit easier than a 534 or 534A. But yeah, that's just from a sample.
Someone's asked a question here about bidding systems, and thanks someone for submitting a bidding system question, because this is the stuff I think about all day. If we use Fluence's software, are we able to make modifications based on personal preferences? For example, would you be using machine learning for price forecasting? Could we tweak the machine learning algorithms based on our preferences? The short answer is yes. So we built a bidding system that seeks to allow an asset owner or the market participant to build up and define their own trading strategy using several configurable inputs and choices and risk management settings. And so there's a lot that you can customize in the bidding system, and it's meant to help asset owners trade their batteries or their hybrid assets however they want. So you can let you can use Fluence's machine learning price forecasts, or you can use AMO pre-dispatch, or you can pump in your own price forecasts to use in the optimization process. And then you can let the default, the algorithm execute the trading strategy you've defined, or you can use any of several intervention levers we've designed to let you give it a nudge or give it some direction or give it an override, and that's totally fine. Thanks for the question.
Okay, one more from Inez, and I think we'll have two more after this. So put your questions in. I mean, we have a lot left, but with respect to example one, which was that DC coupled one DUID, why is ADC useful if you're always conforming as a scheduled unit? So I think the biggest distinction here between one DUID and two DUIDs is that two DUIDs gives you the flexibility to conform or not conform based on your unders and overs from your VRE. Whereas one DUID, you have to follow dispatch targets at all times, and maybe you cycle your battery more as a consequence of that. So the real difference is just flexibility.
Yeah, one way you could think about it is that, the term ADC is quite a specific new mechanism AMO has made available that is essentially only available to two DUID configurations. But one way you could think about it is that a 1D UID hybrid is essentially forced to use aggregate conformance 100% of the time. It's just one big scheduled unit, the same way it looks to AMO, your hybrid looks to AMO like it's a gas peaker or a coal unit that's just, its dispatch target is the dispatch target and you have to hit it, or you run afoul of the conformance rules. So it's the battery's job to make sure 100% of the time the plant hits the target in aggregate at the connection point. Good question.
Okay, we've got a software question for you, Matt. And maybe because this is our second last question, if you want to jump to the slide that has our emails on it, for people who want to contact us after, you're more than welcome. So this one's, with the software, can you also select how risk averse you want to be with your bidding and what markets to expose yourself more to?
Yes, we've tried to design the bidding system to let participants make their own decisions about how they want to manage things like what markets they participate in, and at what volumes and at what prices and at what levels of risk. So we've tried to build the system such that it empowers participants to make those assessments and decisions for themselves. Our team, of course, is available to help guide our customers through those choices and how to implement them in the software. But yeah, we've tried to make it so that the participant stays in control of all those key preferences and risk management settings.
All right, and the last question from Anonymous is, when in the project development lifecycle should we start thinking about bidding optimizer design? For example, should it be before engaging SCADA and control supplier?
Yes, it's a good question. If you're building a standalone battery, I would say don't worry about it. Any bidding system will be compatible with the standalone battery you're building. But for a hybrid plant, it is a bit of a different consideration where you probably want to put your bidding system provider in the room with your engineering team and possibly your BMS or your PPC system supplier, to have a chat about what the physical plant can do and what it can't do, and how to get the right signals off that plant through to the bidding system so that the bidding system can operate the plant within its both efficiently and for maximum revenue, but within the technical limitations of the plant. So the hybrid plants, because there's so many permutations and different types of kit, are going to have a generally wider range of operating capabilities relative to a standalone battery. And so making sure your bidding system of choice can properly accommodate your specific plant is a key question you want to answer early on. At Fluence, we're doing our best to design our bidding system to be as flexible as possible to accommodate the widest array of possible hybrid plant permutations as we can. But if you've got something we've never seen before, or a complex new curly question about how to operate your plant, please bring it to us. We're happy to have a chat. So maybe we'll wrap it up there. That was a healthy Q&A. Thanks everyone for good questions. There's still a few questions in our stack and a few maybe technical ones that would be easier for us to take on notice. So we'll go through the question list after, if you put your name on it, and we'll make sure we flick you an email back with a response. So thanks everyone for joining. Thanks, Sam, for helping me explain this concept, this complex new topic. I hope that was informative for everyone. And yeah, feel free to get in touch with Sam and I if we can. We're happy to have a chat about any of this stuff. So thanks for joining.
Thanks, everyone.